You are standing on the edge of a crater at 2 in the morning, telescope pointed at a gray world 8,000 miles away, and for 1 second, something on the surface flickers where nothing should ever flicker. The moon. Our closest neighbor, the one object in the sky every human has stared at since before we had a word for stare, and somehow, after 60 years of photographing every inch of it, we still do not fully understand what just moved across its surface. If even a fraction of what has been recorded turns out to be real, then the quiet gray rock outside your window has been keeping a secret this whole time. Stick around and hit subscribe before we go further, because the next few minutes will change how you look up at night, and you will not want to miss where this story ends. Because this is not one strange night. This is a pattern that stretches back centuries, quietly logged by professional astronomers who had nothing to gain by lying, and it has never been fully explained. Sometimes it is a soft red glow crawling across a crater floor. Sometimes it is a bright point of light that blinks on and vanishes in under a minute. Sometimes it is a patch of the surface that seems to shimmer, as if heat were rising off a summer road, except there is no air on the moon to carry heat that way. Scientists have a name for this. They call it a transient lunar phenomenon, which just means a short-lived change on the moon's surface that nobody can fully explain. The name is calm and clinical. The reports underneath it are anything but. Astronomers with real telescopes, real training, and real reputations to protect have described watching the moon do something it is not supposed to do, and then watched it stop, as if nothing had happened at all. What makes these reports hard to dismiss is exactly what makes them hard to prove. A flicker that lasts less than a minute, seen through one telescope by one person, leaves almost nothing behind to examine afterward. No photograph, no second witness. Just a trained observer insisting, sometimes for the rest of their career, that they saw exactly what they said they saw, on a world that is not supposed to have anything left to see. So before we go further, let us be honest about what most people believe walking into this story. Most people believe the moon is finished. A dead rock. No air, no weather, no motion, nothing left to happen there except sunlight sliding slowly across old craters. That belief feels safe. It feels obvious. And for most of human history, it was treated as simple fact. Let us pull back now and look at where that belief actually came from, because it did not come from nowhere. It came from the way the moon looks through an ordinary backyard telescope on an ordinary night, which is to say, it looks like nothing is happening at all. The moon formed a little over 4.5 billion years ago, most likely after a Mars-sized object slammed into the young Earth and blasted a ring of debris into orbit, debris that slowly clumped together into the pale companion we see tonight. For the first billion years or so, it really was active. Molten rock, volcanic flows, impacts hammering the surface into the shapes we recognize today. Then, slowly, it cooled. It went still. By the time anything on Earth had eyes to look up with, the moon had already settled into the silence we now take for granted. That silence is why we love it. There is something comforting about a moon that never changes. Ancient farmers used its phases to plan harvests. Sailors used it to find their way home across open water. Poets used it as a symbol for anything constant, anything you could count on, precisely because it seemed like the one thing in the sky that never surprised anyone. Close your eyes for a second and picture the surface itself. The way it actually looks up close in the photographs sent back by orbiters and landers. Fine gray dust, soft as flour but sharp under a microscope, scattered across a landscape of round craters stacked on top of older, half-erased craters. No wind to smooth the edges, no rain to wash anything away. Every footprint the Apollo astronauts left in 1969 is very likely still sitting there today, exactly as sharp as the day it was pressed into the ground, because there is nothing on the moon to disturb it. That absence of change is not an accident of bad luck. It is basic physics. Without an atmosphere, there is no wind to blow dust around and no rain to erode a mountain. Without liquid water, there is no river cutting a new canyon over centuries. Every process that reshapes the Earth, constantly, quietly, in the background of our daily lives, simply does not exist on the moon in any meaningful way. So when something changes there anyway, it stands out far more than it ever could here. Even the greatest astronomers of the past treated the moon this way, as a fixed backdrop rather than a living stage. Galileo pointed his telescope at it in 1609 and marveled at mountains and craters. But he was mapping a landscape, not watching for movement. For centuries afterward, lunar science mostly meant drawing better maps of a surface that everyone assumed was frozen in place, the same yesterday, today, and 1,000 years from now. Think about what that actually meant for the people doing the work. Generations of astronomers spent entire careers sketching the same craters by candlelight and later by electric lamp, comparing their drawings to older maps, checking for mistakes rather than checking for change. Nobody expected the ground itself to shift. The whole point of drawing a map is that the thing underneath it stays put. That habit of mind became a kind of inherited certainty, passed from teacher to student for hundreds of years without anyone stopping to question it out loud. Textbooks describe the moon in the past tense, as if its entire story had already finished billions of years ago, and all that remained was for humans to slowly catalog the leftovers. It made the moon feel safe. It made the moon feel small, in the sense of already fully known. That assumption held for so long that it became almost invisible, the kind of belief nobody bothers to question because nobody thinks to ask the question in the first place. The moon does not move. The moon does not change. Whatever craters are there today were there 10,000 years ago and will be there 10,000 years from now. That was the picture. That was the story everyone quietly agreed to believe. And then, every so often, across hundreds of years, a careful observer looked up and saw something that did not fit the picture at all. The earliest known account comes from monks at Canterbury in the year 1178, who wrote that they watched the upper horn of a crescent moon suddenly split apart, with fire, hot coals, and sparks shooting out of it. Modern researchers have debated for decades what those monks actually saw, with some suggesting it may have been an unrelated meteor burning up in Earth's own atmosphere directly in front of the moon, rather than anything happening on the lunar surface itself. But the account survived, written down by people with no telescope, no reason to invent a story, and no audience beyond their own monastery walls. By the time real telescopes existed, the reports kept coming, and they kept coming from people whose entire careers depended on careful, boring, reliable observation. Sir William Herschel, the astronomer who discovered the planet Uranus in 1781, reported red glowing spots on the moon on more than one occasion, describing them in his own notebooks as looking like a fire burning quietly beneath the surface. He was not a storyteller looking for attention. He was one of the most respected scientists of his era, and he wrote it down anyway. So this is the assumption most people carry into a story like this one, without ever really examining it. The moon is dead. The moon is finished. Whatever we see up there tonight is exactly what our ancestors saw, and exactly what our grandchildren will see, forever unchanging, forever the same quiet gray face in the sky. But that picture is about to change, and not because of one strange night 300 years ago. It is about to change because of what happened once human beings finally had the instruments to watch the moon continuously, carefully, and scientifically, instead of catching brief glimpses through a single eyepiece on a lucky evening. Go ahead and drop a comment right now describing the moment you first realized something you always assumed was true might not be. Because stories like that are exactly what shape which mystery we dig into next. In 1958, a Soviet astronomer named Nikolai Kozyrev pointed a spectrograph, an instrument that studies light in incredible detail, at the crater Alphonsus and recorded something that should not have been there. The light signature matched a gas cloud, as if something had just vented from beneath the surface. Kozyrev published his findings, and the astronomy world reacted with a mixture of fascination and deep suspicion, because a moon that vents gas is a moon that is not entirely dead. 9 years later, in 1967, the idea got a second life when Cornell University astronomer Winifred Cameron began systematically collecting every historical report of unusual lunar activity she could find, sorting them by location, date, and description, and building what became one of the first serious scientific catalogs of transient lunar phenomena. Her work mattered because it turned scattered folklore into organized data, the kind scientists could actually study instead of dismiss. Picture the scale of that task for a moment. Cameron was not working with satellites or computers that could search a database in a second. She was reading through old astronomy journals, handwritten observing logs, and letters between observatories scattered across different countries and different centuries, looking for the same handful of words repeated by strangers who never met each other. A glow, a flash, a patch of haze that should not exist on an airless world. Finding the same description twice, 100 years apart, from two people who had never read each other's notes, was the first real hint that something consistent was happening, not just imagined. Then, in November of 1969, Apollo 12 astronauts orbiting the moon reported an odd glow near the crater Aristarchus, one of the most frequently reported locations for these events, and radioed it down to mission control in real time. These were trained pilots and engineers, chosen precisely because they did not panic and did not exaggerate, describing exactly what they saw as they saw it, with no time to invent a story and no reason to want to. What was expected going into the Apollo years was that astronauts flying directly over the lunar surface would see nothing unusual at all, because the surface was supposed to be geologically dead. What was actually found was a string of independent reports from different missions, different astronauts, and different instruments, all describing brief glows and color changes concentrated suspiciously around the same handful of craters. It was the difference between expecting a silent security camera and instead catching several separate witnesses, all describing the same flicker of motion at the same door. Months later, NASA compiled these reports internally, along with centuries of earlier ground-based sightings, into a working list of lunar transient phenomenon locations, and the pattern held up under scrutiny. Aristarchus, Alphonsus, Plato, Grimaldi, the same craters appearing again and again across 400 years of independent observers who mostly never read each other's notes. In parallel with the Apollo program, ground-based astronomers kept watching too, and in 1970, a University of Arizona team led by planetary scientist Barbara Mittelhurst compiled over 1,400 historical reports of lunar transient phenomena stretching back centuries, cross-referencing them against known lunar geology, and found that roughly half of them clustered around the edges of ancient lava flows called maria, the same dark patches you can see with your bare eyes on a clear night. That clustering mattered enormously because it meant the sightings were not random noise scattered evenly across the moon. Random noise looks the same everywhere. This did not look the same everywhere. It concentrated in specific places over and over, the way smoke keeps rising from the same chimney rather than drifting up randomly from an empty field. Back on Earth, this changed something in ordinary living rooms too, not just observatories. Amateur astronomy clubs that had spent decades treating the moon as the easy, boring target, the thing you point a beginner's telescope at before graduating to more interesting planets, suddenly had a reason to keep watching the same craters night after night, hoping to be the one who caught the next flicker on camera. Out among the stars, the implications reached further still, because if a supposedly dead world like the moon could still show flickers of unexplained activity, then every other quiet moon and dwarf planet in the solar system, places written off decades ago as geologically finished, deserved a second look as well. The moon was no longer just a case study. It was a warning against writing anything off too soon. Then, in the decades after Apollo, a new tool changed the entire investigation. Spacecraft like Clementine in 1994 and the Lunar Reconnaissance Orbiter, launched by NASA in 2009, began mapping the moon's surface in extraordinary detail, not once, but repeatedly, year after year, allowing scientists to directly compare the same patch of ground photographed a decade apart. What scientists expected, comparing those images, was exactly nothing, since a geologically dead world should look identical from one decade to the next. What they actually found in a landmark 2016 study led by planetary scientist Emerson Speyerer of Arizona State University, published in the journal Icarus, was over 200 previously undetected impact craters that had formed on the lunar surface within just the span of the observation window, at a rate roughly 100 times higher than earlier models had predicted. It was the difference between expecting an empty parking lot overnight and returning at dawn to find 100 new dents in the pavement. I will admit, even now, that not everyone studying this agrees on what it all adds up to. Some researchers lean toward outgassing, small pockets of trapped gas from deep inside the moon slowly leaking to the surface through cracks and faults. Others point to electrostatic dust, tiny charged particles lifted and lit by sunlight in ways that can look like a glow from a distance. And a smaller, more cautious group thinks some sightings may simply be tricks of Earth's own turbulent atmosphere distorting the image, nothing lunar at all. The honest answer, from the scientists closest to this data, is that no single explanation accounts for every single report, and that is a strange thing to admit about our nearest neighbor in space. A little further into the decade, in 2018, a team using LRO imaging data cross-checked several of Winifred Cameron's oldest catalog entries against high-resolution photographs of those exact same craters, hoping to find some obvious geological scar left behind, a fresh crack, a shift in color, anything permanent. What they expected was silence, since old reports from centuries earlier seemed too faint and too far removed to ever be confirmed by modern equipment. What they actually found, at a handful of sites, was subtle but real differences in surface brightness compared to older orbital photographs, differences too small to be caused by lighting angle alone. It was the difference between assuming an old rumor was pure fiction and finding, tucked in the back of an old drawer, a single photograph that matches the rumor almost exactly. Meanwhile, the seismic side of the story was quietly building toward its own surprise. Apollo astronauts left seismometers, instruments that detect ground shaking, on the lunar surface between 1969 and 1972, and those instruments kept transmitting data back to Earth for years, recording thousands of moonquakes that nobody expected a dead world to produce at all. Later analysis of that decades-old Apollo data, published by NASA and the United States Geological Survey in 2019, identified a cluster of shallow moonquakes located near the lunar South Pole that appeared to be linked to young fault lines still actively shifting, meaning the moon's crust was not simply an old frozen shell, but a surface still quietly cracking and settling under its own weight. Soon after that discovery, researchers began connecting the seismic data to the transient light reports for the first time, proposing that some of the historical glows might be linked to genuine ground movement, dust kicked loose by a shallow moonquake, catching sunlight at just the right angle to look like a shimmer or a flash from a telescope on Earth. It was a bridge between two mysteries that had been treated separately for decades, and suddenly, they looked like two symptoms of the same underlying condition. A short time after that, planetary geologist Thomas Waters of the Smithsonian Institution, who had led much of the earlier fault line research, pointed out something else worth sitting with. The moon is actually shrinking, very slowly, as its interior continues to cool and contract, the same way a grape wrinkles into a raisin as it dries out over time. That slow shrinking puts stress on the crust, and that stress has to go somewhere, which is exactly what produces the young fault lines and the shallow quakes recorded near the South Pole. What looked at first like a strange, isolated puzzle turned out to be one visible symptom of the entire moon slowly changing shape. Domestically, on Earth, this rewrote something quieter but just as important: the instruction manuals amateur astronomers had been using for generations. Backyard observers who once dismissed a strange flicker on the moon as a trick of their own eyes were now being asked by professional organizations to log the time, location, and duration of anything unusual, because their casual midnight hobby had quietly become real data. Cosmically, it rewrote something bigger, the whole category we use to describe worlds like the moon. For decades, planetary scientists sorted rocky bodies into two neat boxes: geologically alive, like Earth, or geologically dead, like the moon. This new evidence suggested a third, messier category: worlds that are mostly quiet but never fully finished, still cracking, still venting, still capable of a flicker of activity every so often across thousands of years. By the early 2020s, the picture scientists were working with looked nothing like the picture from a century earlier. The moon was no longer a frozen photograph. It was something closer to a sleeping animal, breathing so slowly you would need to watch for years to catch a single breath, but breathing all the same. And here is where this stops being about one gray rock in the sky and starts being about how confident any of us should ever be that we have finished understanding something familiar. If the closest object in the universe to human eyes can still surprise the scientists who have studied it the longest, then the story quietly becomes about how much else we may have already decided is boring, simply because nobody has looked closely enough lately. Send this video to the one person in your life who insists the moon is just a rock, because this is the video that finally gives you the receipts. That shrinking, wrinkling moon changes something else too, something closer to home than any spacecraft. Every future mission planner now has to treat lunar geology the way engineers here on Earth treat earthquake zones in California or Japan, not as a fixed backdrop for construction, but as an active variable that can shift the ground under a habitat, a landing pad, or a road years after it is built. A future moon base is no longer being designed for a dead world. It is being designed for a world that occasionally, quietly, moves. By 2023, mission planners at NASA were treating the lunar South Pole, the same region flagged for those shallow, active moonquakes back in 2019, as the leading candidate landing zone for the Artemis program, the effort intended to return American astronauts to the lunar surface for the first time since 1972. That decision was not made lightly, because a region with active young faults is also a region where the ground itself could shift beneath a future landing site. In September of 2023, a study published in the Planetary Science Journal by a team including researchers from NASA's Jet Propulsion Laboratory modeled how a magnitude 5 moonquake near that South Pole region, roughly comparable to a moderate earthquake on Earth, could trigger landslides on nearby crater slopes, sending debris skidding for miles across terrain some future mission might need to walk across. That is not abstract history anymore. That is an engineering problem for a mission with a real, dated target. Unresolved questions remain, and honestly, that is part of what makes this story worth continuing to watch rather than filing away as solved. Nobody has yet caught a transient lunar phenomenon on camera with enough resolution and enough matching instruments at the same moment to settle, once and for all, which explanation fits which sighting. The catalog keeps growing. The explanations keep competing. The moon keeps its answer to itself. There is also the question every viewer eventually asks once they hear a story like this one, whether any of it could point to something beyond geology entirely, something built rather than something geological. Serious researchers are careful here, and for good reason, because extraordinary claims need extraordinary evidence, and right now every confirmed transient lunar phenomenon still fits comfortably inside natural explanations: outgassing, dust, seismic shaking, or atmospheric distortion back here on Earth. But the honest reason this mystery still grips people, decade after decade, is that nobody has fully closed the door on every single sighting yet, and until every last case is explained, a small, careful, scientific curiosity is allowed to stay open. That is not the same as saying anyone is hiding evidence of visitors. It is closer to saying that science, done properly, refuses to slam a door shut just because the answer on the other side would be less exciting than the mystery itself. The moon has earned the benefit of patience, 400 years of it, and researchers studying it now are still choosing patience over easy answers. What is being planned next is more coverage, not less. The Lunar Reconnaissance Orbiter, which first caught those 200 new impact craters back in 2016, is still operating in 2026, still photographing the same terrain again and again, quietly building the kind of long-term data set that finally lets scientists tell the difference between a coincidence and a pattern. At the same time, a growing international network of amateur astronomers, coordinated through organizations like the Association of Lunar and Planetary Observers, is logging suspected transient phenomena in real time, using nothing more than backyard telescopes and a shared reporting app, meaning the next confirmed sighting could just as easily come from someone's driveway as from a space agency's control room. That kind of open, shared reporting would have sounded impossible to Winifred Cameron back in 1967, sifting through paper journals one letter at a time. Today, a single suspicious flicker photographed in one country can be cross-checked within minutes against a report logged in another country on the opposite side of the planet, compressing what once took years of patient archival digging into something that can now happen before the moon has even finished setting for the night. That is the domestic anchor worth sitting with for a second. Somewhere tonight, an ordinary person with an ordinary telescope, maybe not so different from the one gathering dust in your own closet, might be the one who finally captures the clearest evidence yet of a moonquake shaking dust loose at exactly the right angle to catch the sunlight. The next real answer to this 400-year-old mystery might not come from a billion-dollar spacecraft. It might come from someone's backyard on an ordinary Tuesday night. Zoom out to the scale of the whole mission timeline, and the precision only sharpens further. NASA's current public target for the first Artemis crewed lunar landing sits in 2027, part of a schedule that has already shifted more than once, which means the exact date the first new human bootprint appears near that seismically active South Pole is still genuinely unknown even to the people planning it. What is known, down to the level of individual candidate landing ellipses, only a few miles wide, is which slopes near that region carry the highest calculated landslide risk based on the 2023 modeling work, meaning engineers today are already weighing decisions shaped directly by moonquakes recorded on instruments left behind more than 50 years earlier. Something is coming for this story, even if nobody can tell you the exact date yet. Somewhere on Earth tonight, a telescope is already pointed at the moon, waiting, and somewhere on the moon, a fault line older than human civilization is settling by some impossibly tiny fraction of an inch, the kind of motion nobody would ever notice unless they happen to be watching the exact right crater at the exact right second. That is the strange privilege of living right now, in this decade, with orbiters circling overhead and seismometers once buried in gray dust having already whispered their secrets back to Earth. We are the first humans in history with enough data, collected across enough years, to start asking better questions than curious, wondering, and afraid. We can finally ask specific ones. Which crater? Which fault? Which kind of light? Which decade this settles for good? Picture one single frame of video, still years away from being recorded by some instrument that may not even exist yet, showing a soft glow spreading slowly across the floor of Aristarchus crater, while two separate observatories on opposite sides of Earth record the exact same flicker at the exact same second. That single frame, if it ever arrives, would end a mystery that monks first wrote about in the year 1178 and that Herschel described in his own notebooks centuries later. Until that frame exists, the moon keeps it secret, patiently, the way it has kept it for longer than anyone alive has been watching. But the watching itself has changed everything. 400 years ago, a strange light on the moon was a story a monk told his brothers by candlelight. Today, it is a data point, cross-referenced against seismic records, satellite imagery, and centuries of careful notes from astronomers who trusted their own eyes, even when nobody believed them. Think about how quietly that shift happened. Nobody announced it. There was no single headline that read, "The moon is alive again." Instead, one dataset connected to another. A seismometer reading from 1972 lined up with a photograph from 2016. A monk's handwritten account from 1178 lined up with a spectrograph reading from 1958. And slowly, without any single dramatic moment, an old dead rock turned back into an open question. That is usually how the biggest shifts in understanding actually happen, not as one lightning bolt of discovery, but as 100 small, careful observations finally lining up in the same direction. The scientists who noticed it were not chasing headlines. They were just refusing to stop looking, refusing to accept the easy old answer simply because it was comfortable and familiar. Save this video before you go, or set a reminder to check back in a year, because the next major lunar mission update could be the one that finally connects one of these old glowing reports to a real, confirmed cause, and you will want to already understand exactly why it matters. Somewhere between a monk's candlelit notebook in 1178 and an orbiter still circling quietly overhead in 2026, the moon stopped being the one thing in the sky we were allowed to stop paying attention to. Somewhere out there, right now, a fault line is settling by a fraction most instruments still cannot measure, and one day soon, some instrument that does not exist yet will finally catch it clearly enough to end the guessing for good. When that day comes, it will not feel like a monster movie reveal. It will feel like a quiet confirmation of something patient people suspected for centuries and refused to stop checking. It never stopped moving. We just finally started watching closely enough to notice.